Okay, on today's lesson, we're going to talk about predictions, making predictions. So first, we're going to make a prediction. You know, it's really hard to write on this thing. And justify mathematically well, there's an A in there, y'all, from a table. We're also going to make a prediction from a scatter plot. And make a prediction based on context or real world information. Okay? All right, so let's look at making a prediction from a table. All right, so this is kind of like what we've been doing, finding the other terms, the extended terms. You're extending the table out and finding the terms. All right, but this time we want to pay attention to the x's as well. All right, if you look here, we're adding 2. It looks like we're going to add 2 each time. And over here on the output, we're adding 4. Adding 4. So we're adding 4 as well. So if you think about rate of change, all right, the change in my y over the change in my x. So the change in my y values, which was plus 4, over the change in my x values, which was plus 2. And if you simplify that, 4 divided by 2 is 2. Or you could say 2 over 1. So rate of change, you call it rate of change when you're talking about real world and context. But if you're dealing with the slope of a line, you're talking about slope, okay? So it's the same thing. Rate of change and slope is the same thing. So every time my y value increases 2, my x value is increasing 1, okay? All right, so that would mean if it went up, my input was 1, so for every 1 in my x, it's going up 2 in my y, so my output would be 10, right? Okay. All right, so it says make a prediction about the output when the input is 10. So if they're going up by 2 here, we can just go ahead and say 6, 8, 10. So if we went up 2 here, it went up 4 here, right? So 20 plus 4 is 24. And if I go up another 2, then I'm going to go up another 4. So this would be 28. So if my input is 10, my output is 28. Okay? And that's linear, right? Right. All right, let's look at this one. It looks like we're going up 1 every time. Over here on this side, we're going down 8. So it looks like we're decreasing by 8 each time. So my rate of change is going to be negative 8 over 1, or negative 8. So every time my input increases by 1, my output decreases by 8. Okay, that's that relationship between your input and output. It says make a prediction about the output when the input is 7. So we need to go ahead and extend this table to 4, 5, 6, 7. So we're going to go down 8, and that would be 70. So down 8 is 62. Down 8, 54. Down 8 be 46. Okay, so my input's 7, my output will be 46. Okay, it's just extending those tables out. All right, input, output, they gave us a horizontal table instead of a vertical table, but we're doing the same thing. Our input, which is your X, is increasing by 2. So it's increasing by 2 each time. And then my Y, looks like we're decreasing by 2 here. So the next one, if it's a 6, this would be what? It would be 4. Then decrease by 2 again, you get 2. Decrease by 2 and you would get 0. And then decrease by 2, you get -2. Okay, so if the input is 6, the output will be 4. And if it's 10, my output will be 0. Okay, what's my rate of change on this? Okay, this you have to be careful. It's your change in your Y over your change in your X. So my change in my Y was -2. Change in my X was +2. So my rate of change is -1. Okay, for every time input goes down 1, your output goes up 1. Oh, excuse me, vice versa. If your input goes up 1, your output goes down 1. All right, let's look at this one. It says make a prediction for the depth after 7 minutes. All right, so we got time in minutes here. It's 2, 4, 6, 8. So they're going up by 2. And if you look, 7 minutes would be in between here, correct? So our output's going to be in between 13 and 19. In fact, it's going to be halfway in between, because halfway between 6 and 8 is 7. So halfway between 13 and 19. So if you say 19 minus 13, you get 6. And then half of that is 3. So halfway point would be +3, right? So it's going to be 16. It will be halfway in between there. Okay, so it's 16 centimeters in depth. All right, let's go to our next page. All right, so we're looking at this graph, and it's the depth of water at 2-minute intervals. So here's the depth on this side, and this is the 2-minute intervals. It said, can you predict the depth of water at 26 minutes? All right, and this is a scatter plot. It's not quite linear, it just about is, but 26 minutes would be our next interval, right? So if you draw a line through the middle of these dots, that's going to kind of give you an idea of what 26 would be. So if this is going up by 5, then I would say it's probably going to be, your next step here would be 55, right? So I would say, and it'd be an estimate of about 55 centimeters. And this is about, right? Okay. All right, let's look at this scatter plot. And I always tell kids when they're taking like the EOC test, if it was paper and pencil, to just get you a a straight edge. And let me see if I can do a line on this. I don't know what that is. Well, that's not going to do me a line. No. If I had a line that was going straight down through here, this is probably going to do a box. Yeah, it's going to do a box. I don't want that. Okay, let me just try to draw a straight edge. If I'm doing a straight, trying to do a straight edge through this paper, this graph, then I would kind of try to center your paper or your straight edge where it's going right through the middle of all these dots, and then just kind of draw you a line. And that's not very straight, is it? Okay, so kind of draw a straight line through the middle of all those. And it says, use the scatter plot above to predict a reasonable test score for 4.5 hours of television. All right, so this is 4 hours, this is 6 hours, so this is 5, so we're in between. So you're going to be somewhere in this area. So this would be 80 hours. All right, so I would say halfway between 75 and 85. 70 and 85, so about 75 hours. 75 would be your score. All right, for 4.5 hours. All right, let's see this one. So if I'm going to draw a straight edge through the middle of these dots, it'd be about like that. And it said, what's a reasonable test score for 10 hours? So it's 6, 7, 8, 9, 10. So this would be 10 hours here. So we're going to be about here. So then, let's see, 70, 80, 90. This is 100. All right, so if we're here, it's going to be somewhere between 95 and 100. Okay, probably closer to 100. All right. Let's go to the next page. All right, we've got this scatter plot, and it's kind of all over the place, but you've kind of got it says, could you make a reasonable prediction about the final score for a student who scored an 80 on the quiz? All right, so if this is 80 on the quiz here, it's going to be somewhere about right in here, this area. So if I'm going over, this is 80 and this is 70, so I would say he's going to be between 70 and 80. Well, no, not quite to 80. How about between 70 and 75? Okay. And it says your friend Paul is starting, oh Lord, another guy mowing. Your friend Paul is starting a mowing business. He will start off making $20 per lawn. Before he can start working, he has to buy a lawnmower that costs $300. Make a prediction about how many lawns Paul has to mow to pay off the lawnmower. All right, so if we want to say X, we're going to say X is the number of lawns mowed. And Y is going to be the amount owed. Okay? So at 0 lawns mowed, he owes the $300 where he bought the lawnmower. And our rate of change is for every yard mowed, his balance goes down $20, right? So it minus 20, so this would be 280 would be his balance after he mowed 1 yard. Okay, and you could keep on doing this with your table, which this is what the objective was, for making predictions using tables. And I can keep doing this. Let me keep doing this. This is the objective. 7 is 160. 8 is 140. 9 is 120. 10 is 100. 11 is 80. 12 is 60. 13 is 40. 14 is 20. And 15 is 0. So after 15 lawn mowings, the mower will be paid off. Okay? Now, I do want to say, even though our objective is making prediction using the tables here, and we did that, we made out this big table, that there's a couple other ways you could do this. Do you remember when we did our arithmetic sequence? Your formula is d times n minus 1 plus a. Well, our difference on this one was minus 20, n minus 1, and our first term was 300. And if I simplify that, distribute, it'd be negative 20n plus 20 plus 300. So negative 20n plus 320. All right, so we want when it's 0. So 0 equals negative 20n plus 320. So you could subtract that. Negative 320 equals negative 20n. Divide by negative 20. And you're going to get 15. Okay. So you could do that as well. Can you take a parent call? Okay. Just want to kind of remind you of those arithmetic sequences, which is the same thing as writing this equation for a real world. All right, and let's look at the back page of our notes. It says Sam wants to go surfing on vacation. It will cost him $39 for beginner lessons and $13 per hour to rent a surfboard. If Sam budgeted $120 for surfing on vacation, make a prediction about how many hours he can surf. All right, so he's got to pay the $39 regardless of how many hours he does, right? So it's $39 plus $13 per hour, so times X. And X is going to be the number of hours. Okay? All right, so we've kind of got an equation there. But if you do a table, the number of hours surfing, and then his cost, his money spent. If he did 1 hour surfing, it would be 39 plus 13 for 1 hour. That's $52. If he did 2 hours, it would be 39 plus 13 times 2, which is 65. If you did 3 hours, it would be 39 plus 13 times 3, which is 78. And what are we doing each time here, y'all? We're going up for that additional hour, $13, right? So let's just start going up by 13. So 4 would be, we add 13, it would be what? So 91. And 5 hours, be plus 13, would be 104. 6 hours plus 13 would be 117. And 7 hours would be 130. Now, he only has a budget for 120. Can he do 7 hours? No, because that's going to be $130. 6 hours is 117. So the most he can go is 6 hours. Okay. You could also just make this an inequality. 120 is our max, so it's got to be this has got to be less than or equal to 120, and you could solve it that way. I think you'd come up with like 6 point something, so 6 hours would be the most. Okay. Says you're running late for a dentist appointment. If the dentist is 20 miles away and you can drive 40 miles per hour, make a prediction about how long it will take you to get there. Okay, so if you can go 40 miles in 1 hour, which is 60 minutes, then how long would it be for 20 miles? Would be how many minutes? So we need to solve for x, right? So really, y'all, you can look at this. Half of 40 is 20, so half of 60 would be 30, right? Or you can just cross multiply if you're not sure, if you didn't see that. 40 times x equals 20 times 60 is 100 and, wait, it says 1200. So 6 times 2 is 12, and you got 2 zeros, so 1200. And then divide by 40, so x equals 20. All right, so it take him I did 30 there, y'all. Whoops. Be 30. Okay, 30 minutes. Okay. All right. So you've got a sheet that it's just a few problems using your table and then kind of making prediction based on scatter plots. All right. Do that and upload it. All right. Thanks, y'all.